I picked up a couple more problems from your homework here. And the first one, I've got the natural log of x and just dx. So consider that 1 times dx. So we've got an algebraic function as our 1, and this is our ln of x. So we should attempt to use ln of x as our u. It's u, and that's dv. So our u is equal to ln of x, which makes du equal the derivative of that, which is 1 over x dx. And then we have our dv. Well, it's 1 times dx, and the integral of 1 is just x. So remember, the integral of u dv equals u times v minus the integral of v times du. All right, so that means, let's try a different color here. This equals ln of x times x, that's our u and our v, right? Minus the integral of v, which is x, times du, which is 1 over x dx. And that will fit our formula up here. I'm going to clean this first part up again. That's going to be x ln of x. We'll just leave that alone for now. And x times 1 over x is just 1. So this is just the integral of dx. Well, similar as we had before, that's just x. And then plus some constant c for our answer. Now let's quickly do a check on this. Let's scroll down a little bit, do a check. So if I took the derivative here, so say if I had y equaling x ln of x minus x plus c, y prime, this would be a product rule. So the first times the derivative of the second plus the second times, derivative of the first times second. So that's 1 times ln of x. And this is our product rule for the first bit. And then minus the derivative of x is just 1. And then plus 0, which is the derivative of c. So x over x is just 1. So this equals 1 plus ln of x minus 1. And actually, this is a 0, excuse me. Derivative of c is 0. So y prime is just equal to ln of x. So there's a check for you by taking the derivative to see, in fact, that x ln of x minus x, when we take the derivative of that, we do in fact get just ln of x. All right, let's try this other one here. So we have x and sine of 2x. So x is same as we had in our number 6 on the previous video. We have an algebraic function. This is our x. And we have a trig function. This is our sine of 2x. We don't have a way to just take u as 2x and get a du of x. That's not going to work, so we'll break these up. So we're going to try to let our sine of, our x just be u. I'll do that in green again. So u is going to equal x, which makes du equal to dx. And our dv is equal to sine of 2x dx, which means v. So here, we would probably need to use substitution to solve for this. So let's talk about that. So for this thing here, for sine of x, sine of 2x, we're going to let u equal 2x, and du will equal 2 dx, which means this is equivalent to 1/2 sine of u. And again, I'm using another u here, but hopefully you know this is u substitution from what we would normally do in just a Calc 1 class. That's du. And the integral of sine is negative cosine, so this would equal negative 1/2 cosine of our u, which is our 2x. And then plus c, but we're not going to use that here. Throw the c in at the end. Okay, so this means our v, the integral of sine of 2x, is negative 1/2 cosine of 2x. And again, we're going to use this formula up top here. So now let me go to blue again, keep it consistent. So this equals u times v, so that's x times negative 1/2 cosine of 2x minus the integral of v. Well, the integral of v, v itself is negative 1/2 cosine 2x, and then times du, so that's our dx. I'll clean up this first part, so it's negative x over 2 cosine of 2x. And then this is going to be plus. We got two minuses here, so it's going to be plus. And now we need to do another, substitution part here. I'm going to take the 1/2 out, and I'm left with cosine of 2x dx. So let me grab another color here. Let's try a red or a plum or something. So here, u will equal, for this will be our u, 2x. du is 2 dx. We have a 1/2 on the outside, so essentially what this means is dx equals du over 2. We need to put another 2 out, another 1/2 out, essentially. Let's go back to our blue. That equals negative x over 2 cosine of 2x. And this is going to be plus 1 over 4, which is 1/2 times 1/2, cosine of u du. So the integral of cosine is just straight up sine. So that's going to equal, so plus 1/4 sine, well, u is 2x, so sine of 2x, and then plus some c. Again, as an exercise, take the derivative of this to verify that you end up with what we started off with.